All right, today we're talking about Bernoulli's principle. And basically the principle says as speed increases, pressure decreases. Now we're talking about a fluid. A fluid, remember, is either a liquid or a gas. Is something that moves. Remember, we're talking about a fluid. We're talking about something, the particles has enough kinetic energy for it to slip out of place, or a gas where the particles have enough energy to move freely. Air molecules, as we saw yesterday in class, air particles actually produce a lot of pressure that we are very accustomed to because we've had it all our life. Well, when these particles are not moving, and when I say not moving, they're still, again, random motion going around, but they're not flowing away from us, they still have pressure. But when something comes along and moves these particles faster, they lose their pressure. You would think that would be the exact opposite, that because they're moving, they have more pressure, but they actually have less pressure. So at this area right here, you have something that's moving, a fluid that's moving, and here you have actually a greater pressure that's out now pushing toward that area that's actually moving fast. One good example is a tennis ball. This is a hair dryer, and if I put a tennis ball on the very top right here, what you expect to happen is for the tennis ball to fly off to the side. Well, let's see exactly what happens. So what's keeping the tennis ball flowing up here? Well, I'm going to draw the side view first, and I'll draw a top view. But the hair dryer, again, air particles are all here, all around us. And the tennis ball, I'm going to go ahead and draw the tennis ball from the air. The hair dryer has a fan that's pulling in air particles and blowing them out. Well, the air particles flow, they have a lot of speed here, whereas the particles out here to the side are not moving. So they have a pressure that's pushing inward. And that's what's keeping the ball in place. The ball's not going off either side because the air particles out here are basically pushing and keeping the ball in place. Now, if we were to look directly straight down on top of it, what we would see is all the air particles pushing in on the ball, keeping the ball right over top of the hair dryer. So again, instead of the ball flying off the side, it just goes straight up in the air. Another example, I have a piece of paper here, okay, and I'm gonna take the piece of paper to this block. Tape's too hard to get off. Use this. So I'm going to take this piece of paper and I'm going to tape it right across here. Now you see the paper sitting down. Well, when I begin to use the hair dryer again, I'm going to draw this up for us. Here we have the block, we have the tape paper, taped right here. I'm going to use the hair dryer and I'm going to move the air that's here. Well, if this air is moving, it has less pressure and this has more pressure. So what should happen is this paper should move up and basically be flat across the top. Should go all the way across the top. So let's see. Again, just a quick little example of Bernoulli's principle. Whereas the air flowing, moving, has less pressure, and the air that's not moving has more pressure and brings the paper up. People, this is why airplanes actually fly. Bernoulli's principle is one of the key components of why airplanes actually fly. Airplanes have wings. And as the airplane moves through the air particles move over the wing and under the wing. Well, the air particles that move over the wing is actually a further distance to travel over the wing than it is under the wing. And because it's a further distance, these particles have to move faster than the particles under the wing. Again, the more speed you have, the less pressure you have. So you have less pressure pushing down, and you have more pressure pushing up, and we call this lift. And so as the plane gets to a high enough speed, it actually lifts the plane up in the air. Bernoulli's principle: as speed increases, pressure decreases.